Hello, today we're going to be discussing section 2.3, which is on reflections. Our essential question for the day is how can you use reflections to classify a frieze pattern? The word reflection simply means that an image can be replicated by folding it across a particular line. For example, if you see a mountain by a lake, you can see the reflection oftentimes in the lake. So you see a mirror image of that mountain or image in the lake below. In the picture on the right, you can fold the paper along the horizontal line, which we'll call an axis, and the mountain will be reflected across that line. You can almost imagine stamping the image when you fold it on the other side of the fold. Another definition we'll talk about is a frieze pattern. A frieze is a horizontal band that runs at the top of a building. It's often used to decorate the top of a wall or the top of a building. Frieze patterns are translations of themselves, meaning that we take one image and simply translate it down along the top of the wall to create the rest of the image. So if I look at this frieze pattern here along the top of this wall, and I take one section of that frieze pattern to create the rest of the decoration, I would simply take this image and slide it down to fill in the next block. I would then slide it down to fill in the block after that, and so on. Some frieze patterns, however, can be reflections of themselves, meaning that I would take the first image, and in order to get to the next one, I would fold that image over a vertical line. Folding it over, I would then create the next block in my pattern. A reflection can also be referred to as a flip, and the line that we flip that image over is what we call the line of reflection. You can almost think of it as your mirror. If you were looking into a mirror, you would be the original. We have the mirror as your line of reflection, and then your reflection would exist almost on the other side of that mirror. In example 1a, we're going to tell whether the blue figure is a reflection of the red figure. So starting with the red figure, what we want to know is, can we take this red figure, fold it over our line of reflection, and almost stamp it on the other side to end with the blue figure? In example 1a, our answer here is yes. If we stamp that red image on the other side, it will stamp right on top of the blue image. For example B, if I were to fold this image, this red image, over my line of reflection and stamp it on the other side, when it stamps, it would look more like this, which is not the image that we have with our blue figure. The blue figure is simply a translation, not a reflection. So this one for part B is no. Go ahead and try 1, 2, and 3 on your own. Example 1 would be a no, because we simply translated the figure, we didn't flip it. Number 2 would also be a no. If we were to have flipped it, the vertical side of the triangle would be towards the left, but instead it's towards the right. Example 3 would be a yes. When we do flip that red image over the line of reflection and stamp it on the other side, we do get that blue image. We can also reflect in a coordinate plane. Now, if we're looking at particular ordered pairs, let's say I look at the point A, which has the coordinates -3 for x and 1 for y, and I wanted to reflect that point over the x-axis. What that means is that this horizontal line, the x-axis, is now my line of reflection, and I want to flip A over that point, or fold it to the other side. So instead of going 1 unit up to get to A, when I fold it, I'm actually going to be going 1 unit down from that line of reflection. So I would end up at A prime, which has the coordinates -3, because we didn't move left or right at all. We left our x value the same. But instead of going up 1, we went down 1, so our y value becomes negative. So if we are flipping over the x-axis, all that happens is we change our y values from positives to negatives. Instead of going up to our points, we are now going down to the points. Or we could say that in reverse. If we were going down to the points, we could go up to the points instead. Either way, flipping over the x-axis causes your y values to simply change their sign. Now, if I wanted to go from A to A double prime, A has the coordinates -3, 1, and I want to now flip it over the y-axis, or I want to do a vertical reflection of my original triangle. When I fold my graph over this vertical line, I'm not moving anything up or down at all. I'm simply going to take my A value, move it from here, and fold it directly over to land on my A double prime. So instead of going to the left, I will actually be moving to the right to get to my new A value. Originally, we went to the left 3 units, but when I fold my graph over this vertical line, I will be going to the right 3 units. So instead of having a negative x value, my new A value, or A double prime, will have a positive x value of 3. But notice that we didn't move up or down at all, so my y value still stays that positive 1. In algebra, or algebraically, we can see these relationships between our original points and our reflected points by looking at our ordered pairs. If we're reflecting vertically or over the x-axis, we're going from the top to the bottom or from the bottom to the top. All it changes is our y value. It either goes from positive to negative or from negative to positive. If we're reflecting over the y-axis, this means we're folding horizontally, so either from the left to the right or from the right to the left. In this case, our x values will be the one to either start positive and go to negative values, or to start negative and end up as positive values. In example 2, we have a triangle with the vertices A is -1, 1. B has the coordinates -1, 3, and C has the coordinates 6, 3. Drawing this triangle in our coordinate plane, I have A is -1, 1, B is -1, 3, and C is 6, 3. So this would be the triangle that they've given me in the question. We're going to draw the figure, which we've just done, and then reflect it over the x-axis. The x-axis is the horizontal line, so I am going to flip my image down over that horizontal line. To do so, I'm going to simply fold my image straight down. So instead of going up to each of my points, I'm going to be going down to each of my points. This does not move my image at all to the left or to the right, only up or down. So instead of going left 1, up 1 to get to point A, I'm going to go left 1, down 1, and this will be my A prime. So my new coordinates for A prime, I still have an x value of -1 because we didn't move left or right, but instead of +1 for y, I have a -1 for my y value. For B, I go left 1, up 1, 2, 3. So to reflect it, I'm simply going left 1 and down 1, 2, 3. So my new B coordinate is B prime, which is located at -1, -3. Again, that x value does not change. Now to get to C, I go to the right, 1, 2, 3, 4, 5, 6, and then I go up 1, 2, 3. So to get to C prime, I'm still going to the right 6, but I'm not going up 3. Instead, I'm going to be going down 3, which gives me a y value of -3. So my reflected image is going to be this red triangle. In example 3, we're going to repeat this, except with a quadrilateral over the y-axis. So my quadrilateral has the coordinates P, which is located at -2, 5. Q is located at -1, -1. R is located at -4, 2. And S is located at -4, 4. -2, 5. 1, 2, 3, 4, 5. I've got Q at -1, -1. I've got R at -4, 2. And I've got S at -4, 4. So here is my quadrilateral. It kind of looks like a kite. We're going to reflect that over the y-axis, which means we're going to fold it horizontally. So to fold it horizontally, I go up the same amount of numbers, or the same distance, but I go to the left to get to P, while the reflection will actually have me going to the right that distance to get to P prime. So my P prime will be located at the same y value, but the x value will now be flipped to a positive. So instead of -2, I have +2, 5. P prime is located here. For Q prime used to be located at -1, -1. That y value stays the same, but instead of -1 for x, I have +1 for x and -1 for y. For R, I had the coordinates -4, +2, but my x value changes to positive while my y value stays. And lastly, S has a negative x value which changes to positive, and my y stays positive. So my new coordinates are 2, 5. I already have that graphed. I have 1, -1 for Q prime. I've got 4, 2 for my R prime, and I've got 4, 4 for my S prime. So my new image will be this figure here, which does look like it's been folded over that vertical y-axis and stamped on the other side. Go ahead, take a moment to pause the video and do number 4 on your own. Draw the figure and its reflection in the x-axis. I did that in red in part A. We simply take our old rectangle and fold it up over that horizontal line of reflection. In part B, I did the reflection over the y-axis in blue. So again, we simply fold that figure over our vertical line of reflection this time and stamp it on the other side. Part C, are the images in part A and B congruent? All we did is we flipped our image around. We didn't stretch it. We didn't make it larger or smaller by any means. We simply flipped it over. So in part C, our answer would be yes. We didn't change the image itself. We really only changed its location. And we also changed its orientation. Meaning instead of facing one way, it's now facing the other way. Thanks so much for watching. This concludes our lesson on reflections.